is 4, C is 25. Okay, so we're told to evaluate the discriminant. We want to check this other side. 4 times 4 is 16, 16 times 25. So let's find out what it is. And we decide what happens to the discriminant. So what is 16 multiplied by 25? It's 400. Therefore, the discriminant is 0. 400 minus 400, it is 0. So it's time for decision. The discriminant is 0. Choose the correct answer. One solution. One rational solution. One solution. That's it. Okay. Number 34, another one that says find the discriminant. And by the way, this is homework 3.3. So we're almost doing all the homework here. Let's do number 35, discriminant again. So this one, find the discriminant. So in this particular one, we have b squared. So negative 4 squared minus 4ac and 4 times c. Negative 4 squared is 16. 16 minus 16 is 0 again. Wow, one real solution or one rational solution. All right, so the discriminant in number 35 is, I don't want you to think that it's going to be 0 all the time. So let's find the one that's not 0. Okay, well, let's do number 34, because I'm sure this one is not going to be 0. All right, so the discriminant here is b squared, so 9 squared minus 4 times a is 8 times c is 4. 9 squared is 81 minus, so let's get a calculator, 16 times 8. 16 times 8. And we have 128. So 16 minus 128, you already know that the value inside the radical sign is negative. Therefore, you have two imaginary solutions. Two imaginary solutions. I hope you agree. If you subtract 128 from 81, you have negative. So you have two imaginary solutions. The two of them, one is the real part, the other one is the conjugate. For every solution that is imaginary, that is the real part, that is the conjugate. And by the way, remember to write the answer, the imaginary solution, in standard form, where the real part is without I, the imaginary part has I. All right, I think we can only get to this point today. Let me see what we can do within this time. So this is 3.3 homework, which you should be doing today. So we started 3.1, 3.2, 3.3. I hope you will do the homework for today. Let's go to 3.4 and see what is in there. We may not even get to do it, but we just see what is in there. And then next class we do 4.2, 4.1, 4.2. We still have 5 sections to go, by the way. Next class we do 5 sections. So anyway, let's get to 3.4. And then I'm going to make it big. Find the maximum value. I already showed you how to find the maximum value. Let me tell you, if you don't have time to use the formula, put the function in your calculator. Number 1 of 4.3, put it in your calculator. Draw the graph. Ask your calculator the maximum point. All right, so that's what I'm going to do now. Number 1 of homework section 4.3.4. So I'm going to put in negative 3x squared Okay, and then plus x minus 1. I'm told to find the maximum point. They did not tell me to use any method. So that's important, which means I can use any method I like. So I'm going to graph the function, and I already know it is a maximum. I will ask my calculator to give me the maximum point. Second calc, and number 4 is maximum, and the blinker is at the top. I'll send it to the left, and I want to answer the question, is this a left bound? Yes, it's the left bound. Then I'll send it the blinker to the right. You make sure that you direct the blinker. All right, then is that the right bound? Yes. It's asking me, do I guess the maximum point? Sure, go ahead. So the maximum point is 0.166, or can just 0.17. And if you're told to leave this answer in exact form, what you do is put this number and change to fraction. For example, this is what I'm going to do now. If I want to change the x coordinate to fraction, this is what I'm going to do. I'm just going to go to main screen, and I'll type 0.16666 and so on. And then I go to math, and I'll change to fraction, and I'll hit it at that. I'll try and change it to fraction. It didn't change though, but it should be able to change it to fraction if you're told to do that. Okay. Find the minimum point. The same method. Find the minimum point. Solve the equation with quadratic formula. So you notice that the quadratic formula is going ahead. Now we shall start using application of quadratic formula. But meanwhile, we have 13 minutes going. So what we're going to do now, I want to go to practice test that should be rationalized the complex number. Whenever a complex number is in the denominator, whether you are told to rationalize or not, you should rationalize the denominator. Complex number should not be in the denominator. All right, so let's get a practice question. That way, I want to make sure you know that before. And so unit 2 practice tests is what I'm going to get now. We are looking for a rational function that has complex number in the denominator. So practice test 2, I have it here. All right, and by next class we shall be talking about increasing and decreasing functions, talking about the functions here. So let me see if I have, so I'm talking about complex numbers again, even though I haven't finished talking about it, because there are things you will see that you really want to make sure you know how to do. If I don't have a question here, I'll put 1, because there's one that like that in your test. I'm not seeing 1, but I just want to make sure you know there's a complex number in. Anyway, I'm going to make up 1 now. All right, this is it. Number 40. Everybody look at number 40. Question number 40. How are you going to tackle this question on Monday in a test? When you're given this question in a test on Monday, how would you solve it? It is complex number in the numerator, complex number in the denominator. You are to write the quotient in the form of the standard form of a complex number. All right, I want you to make sure you know that whenever a complex number is in the denominator, you rationalize the denominator. So I'm going to rewrite the whole function, 9 plus 7i all over 1 plus I. Every complex number has a conjugate. So multiply by the conjugate in the denominator. And what is it? The original one is 1 plus I. The conjugate is 1 minus I. The same thing in the numerator, multiply the same thing, the conjugate in the numerator. Then simplify. If you remember, when you multiply with the conjugate, you have actually expanded difference of two squares. So I can actually rewrite it as 1 minus I squared because it's difference of two squares. A while ago, we said that I squared is the same as -1. Whenever I, you square I is same as -1. So this is where we have I, and so I now have 1 minus minus. I'm talking about denominator. 1 minus minus 1 is 2. So denominator is 2. Because the important thing is that the denominator does not contain a complex number. The denominator must not contain a complex number. That is why you are told to simplify. They didn't even tell you to rationalize the denominator because they're trying to see if you remember it or you know it. And then in the numerator, I'm going to use FOIL. FOIL. First, outside, inside, last. Okay, so now I want to simplify the numerator. I already got the denominator. So let's simplify the numerator. All right, so I have 9 multiply 1 is 9. 9 multiply negative I is negative 9I. 7I multiply 1 is 7I. That's plus. 7I multiply negative I is negative 7I squared. Negative 7I squared. One thing we do know is that whenever we see I squared, it is -1. When we see I to the 4th is 1, we already know that. I to the 4th is 1, I squared is -1. So that's how we're going to use here. So this point here becomes negative. Negative is positive. So I'm going to change this to positive. I can take this away. 9 plus 7 is 16. So I have 16 minus 7I plus negative 9I is negative 2I. Negative 2I divided by 2. Okay, so simplifying, I have 8 minus I. My function is now in the standard form of a complex number, where the real part is 8, the imaginary part is -1. Any question? Any question? All right, that's about anytime you're told to find the minimum or maximum value, you can use your calculator. If you don't want to use your calculator, use the formula. And what is the formula? What is the formula? The formula, please. What is the formula? The formula is negative b over 2a, comma, f into negative b over 2a. So that's the formula. All right. So if you're told to use the formula, then go ahead and use the formula. The one thing I'm going to do now, the last minute, is synthetic division. Use synthetic division to do number 43. Synthetic division. The worksheet we're doing now is homework for section 3.4. So we are in our fourth section today. We are in our fourth section today. Homework section 3.4. All right, so I am told to use synthetic division. And if I'm doing synthetic division, I have to first of all write the quadratic function, make sure it's in standard form, and I'll put the division sign. So I have seen that the quadratic function, this is a cubic polynomial though, So the leading coefficient is 1. Coefficient of the other term is 5, 9, 6. It is in standard form. I have collected the coefficients. The divisor is x plus 2, but I'm doing synthetic division. So I'm going to solve x plus 2 equal to 0. So x is equal to -2 is the only divisor I have. Now I am going to divide. Before I start dividing, and by the way, this is synthetic division. Synthetic division. So the first thing I want to do is bring down 1, multiply -2 to 1, and I have -2, plug that -2 here. Add 5 plus -2, I have 3. -2 multiply 3 is -6. Add that -6 here. Add up. 9 plus -6 is 3. -2 multiply 3 is -6. Add that -6 here. If you add it up, you see that 0. So the remainder here is 0. Therefore, -2 is a factor actually. -2 is one of the solutions. X plus 2 is a factor. Therefore, I can now write the quotient. The quotient is, because I divided cubic by linear, the quotient has to be x squared plus 3x plus 3 plus the remainder. There is no remainder. 0 over the divisor. There is no remainder. So I have finished dividing, and my answer is, this is the quotient. Any question? This is another solve by completing the square. And you will keep seeing solve by completing the square. You will keep seeing it. Do we have time? We only have 3 minutes remaining. Okay, so we did justice actually to 3.4. So the next time we come in here, we go to 3.5. So when we come on here, we shall be talking about the polynomials like this, application with Pythagorean theorem, application with polynomials, complex numbers. So now that we have done the quadratic functions, next class will be applications. Next class is going to be 2 days. In 2 days, that's a Thursday. Do you have any question? I told you, if you do your work, you don't have to answer present, because some people said they are working, so I don't want to mark them absent because they didn't come to class. But anyway, I will go and check your work. If you didn't do the work, I'll mark you absent. And then if for one person or two who did not do the test, I gave them zeros, and I'm going to be reporting them. That means they will be dropped. You can't miss a test in a fast track class. You can't miss a test. Any question? Doug, Minor,
No, ma'am.
Trinity. All right. Minor, do you have a question? I don't even know if I called your name. Is it Moran? Lovejoy, do you have any question?
No, I don't.
Okay, great. Okay, I hope you do the homework 3.1 to 3.4. So that next class will come with. That's another example. An example of another function that is discontinuous. This function is discontinuous. It is discontinuous at 1. That's a break there. And then and you could be told to find the value of x at 1. You really have to be careful, because the value of x at 1 is, see, 1, 2, 3, 4. The value of x at 1 is actually 4, because there is no graph at that point. That's a hole. We call it a hole. That's a hole at that point. Are you still Can you still hear me? Hello? Somebody?
Yes, ma'am.
Yes.
Okay, okay, okay. I'm just making sure that, okay, we are still connected. I have to ask you because this is an online class, so I don't want to be talking to myself. And after some time, find out that, okay. Anyway, so what we're going to do now is start solving problems. In other words, I want to go and pull up the kind of questions you will see in the text. Kind of questions you will see in the text. That's what we have already looked at this. I told you there are answers. So we looked at homework for tonight, 1.2. Let's go and look for homework for another one, which is 2.1. So I am going to 2.1. So I'm going to get another homework for tonight, 2.1. All right, so let me go here and, okay. 2.1, you have this homework. When you log into my lab maths, this homework is actually there. All right, so this is 2.1. Remember that the test will contain 7 sections. So this is the second section we're talking about today. So if it seems like I am first, yes, I am, because we are going to meet 2 times before we do a test, today and Thursday. The next time you will be doing the test. So I will do my best to answer the important questions. Okay, determine the intervals of the domain. So this is a cubic function. It's a cubic function. Actually, when you see it, you know. So you are asked to find the domain, the possible x values. So what you want to make sure you know is that this arrow is going down to infinity. You don't know where it's going. So the domain will be all real numbers from negative infinity to positive infinity. All real numbers. And then if it's asking you about the range, even though you think it's only in the first quadrant and second quadrant, you might as well say that the range is from negative infinity to positive infinity. And you should be able to write it. So these are the kind of questions you will see in this section. Determine the interval. So you keep up, and you have to be careful. It says determine the interval of the domain over which the function is continuous. Now we come to continuous. Be careful. The function is continuous from 3 to positive infinity because 3 is included. So if I'm writing this, I can use the interval notation 3, and I can use bracket, comma, positive infinity. You do not enclose infinity with brackets, so it has to be parentheses. So the domain of the function on the interval of the existence is 3 to positive infinity. Okay. Yeah, so this question will kind of question. I wanted to know that there is a discontinuous point here. That's a point of discontinuity here. And the reason why there's a line here is because it's a vertical asymptote. So you have to identify that there is the point of discontinuity actually is a vertical asymptote. All right, so you could be told to find the point where it is continuous and discontinuous. Well, there is no point of discontinuity here. It is the graph here is continuous and it's positive, rising to the right. It is negative this section. It is constant right here. Okay, so you should be able to answer this question. If you cannot answer any of them, you go to PowerPoint or you go to the ebook. I already showed you how to log into the ebook. Okay, so we want to quickly go to section 1.3. What is there? We're going to peep into 1.3. So I am going to take this one off, and I'm going to get the PowerPoint. Let's look at the PowerPoint first. I'm not 1.3, but 2.3, sorry. So there is no 2.2 here. So that's 2.3. And I am going to increase this so it can see it. And then, yeah, it's talking about transformation. Transformation, the kind we did in middle school, but it's still in functions. So use transformation of graphs to sketch this graph. All right, so this is the parent function. Y1 is the parent function, and Y2 is vertical. Notice that there is a shift to upwards. Okay, so it's a vertical translation. Vertical translation. And this one is also a vertical translation, 5 points down. And so you can graph it, you can get your calculator and graph them to see. But you already know that, well, let's graph it. Let's graph them. Okay, so I'm going to get my calculator again, and I will turn my calculator on. That's a whole lot of things you can do with your calculator. Your book actually showed you how to use calculator. So there's no time, but if you do have the time and read all the study, the PowerPoint, the examples, you are good to go. Okay, so the first thing I want to put in is the parent function in Y1. And then I can now put in the Y2, which is x plus 4. But let me first of all look at my Y1. And by the way, it's always good to look at the windows. I like my windows, it's standard. Okay, so I can just graph and see how the parent function looks. Okay, so that is my parent function here. And then when I add 4 to this parent function, so I will go to my Y2 and put in x plus 4. So the parent function should be moving up 4 units. So I'm going to graph, move the 4 units, a vertical translation of a linear function. And then I'll go back to my y function again, and I put in x minus 5, which is still a vertical translation 5 units down. This should be a review for a lot of us. All right, so x minus 5. This time, this is the minus you're going to use. Minus 5. And I'm going to graph all 5 of them, all 3 of them. See, you see, it looks like a tessellation. So this is a transformation of a linear function. All right, I know you can graph this, but you know what? That is, I want you to know where we are now. This is 1.3, and I want you to know we are not doing all of that. I want you to note that number 2 is an absolute value function. Okay, so this is the parent function of the absolute value function. And this is a horizontal translation of the absolute value function. And this is another horizontal translation. All right. If we graph it, we'll see that a negative 2 is 2 units to the right, x minus 2. X plus 5 is going to be 5 units to the left. So this is horizontal translation. and you can put it in there, or we're just going to do one. And by the way, how do I write this? How do we write this? We can actually be told to rewrite this using what is called piecewise defined function. Well, let's graph it first, and then we can rewrite it as a piecewise function. Okay, so I'm going to go to my y and clear all the three functions, and then go to the absolute value function. And I'm going to arrow up again. You can graph it by hand, no problem. But remember, you're going to have 15 to 20 questions in a test, and you have 1 hour to take the test, 1 hour, maybe 1 hour, 30 minutes. So you don't want to be doing one question by hand and your time is up. You'll be timed. You have 90 minutes to take the test next week, even though we are starting today. We have a test because this is a fast track class. So I don't want you to be doing one question for 30 minutes because you have 20 questions to answer. If you can use your calculator well, you are better off. All right, so remember where to find an absolute value function. Go to math, numbers. The first ABS is absolute value. And what is inside that absolute value? X. And so I can just graph it and see how it looks. That is the parent function. That is a parent function for absolute value function. So I'm going to graph. So that is the original function. Now I am going to do a horizontal translation. So I'm going to pull that down, and I go back, get absolute value. Remember, it is math, numbers, absolute value, and then I have x minus 2 minus this minus. And I'm going to graph both of them. See why I said it's a horizontal translation, because it's inside the main function. A horizontal translation, 2 units to the right. All right, so let's go and put in the third one. And this one is absolute value function plus 5 inside the absolute value. Go back to math, to numbers, select absolute value, x plus 5, x plus 5. All right, so now you can graph all of them. So now it looks like another tessellation moving on the horizontal line on the x-axis. So we called it a horizontal translation. We remember it. I know you remember it from middle school, but you know, we're supposed to do it though. All right, so you're going to see some of other transformations. And so this is a radical. This is a radical where the x is a radicand. Okay, so when you graph this function, your y1, we'll just go to, if I graph this, I will have the graph starting from the origin, rising to the right, and increasing throughout its domain. And what do I mean by increasing? I want to say it again. If a graph is increasing throughout its domain, it means at any point on this graph, the slope is positive. See, slope is positive, slope is positive. So you can put it in your calculator and you will see. And because the transformation is inside the radical sign, the transformation is horizontal. It's a horizontal translation again. We can put, let's do that. Let's do it. So anytime I'm given a radical function And that radical is square root. It could be cube root. It could be fourth root. It could be so, but the nth root, the n is 2. All right, so I'm going to clear the absolute value function and then put in the radical. Okay, so I will do second square root. Where do you find square root? I find square root here. Okay, so I will just put, okay, so where am I? See you clearly. Oh, not you. Okay, I am looking for second square root. Okay, and then I'm looking for x. So I just put x in here, and then you go back to y2. You do the same, except that the translation is 6 units to the left. Remember, if you're adding a constant, it is to the left. If you are subtracting, it is to the right. So second square root x plus 6, x plus 6. And then the third one is second square root x minus 6. Remember to use this minus when you have more than 2 terms. All right, so my Windows is still good. It's a standard window. I can get what I have. So I'm going to graph. So this is a horizontal translation of the square root function. A horizontal translation. And notice that each one of them is increasing. Every one of them. They are increasing throughout the domain. So where are we? We are in section 1.3. You should be able to do the homework when you get home. Sections 2.1, 1.2, 2.1, 2.2. All right. So, and if there's anyone you cannot do, then go back to your PowerPoint and look up examples, or go back to your textbook, ebook, and look up the example. The example is there. One thing I want you to know is that you cannot be sending me every homework. You cannot be sending me every question in that homework, because guess what? There's many of you, and I don't even want to answer all the questions. The essence of giving you homework and giving you section videos and giving you class videos is so that you can find them. You should find them. You know what? What I do is, when I see that 2 or 3 people are asking the same question, then I will do a video of that question. But it's not just when you open a homework and you ask me the first question. No, you should be able to find them, and you can find them. They're not even too far away. You just have to make up time. I know there's no time. Okay, let's look at this radical function again. Well, there are a lot of things going on here. There is a horizontal translation. There is also a vertical translation. You don't really have to use your calculator all the time. You can actually figure it out by eyeballing the function. So the one inside the radical, so look at the radicand. We have x minus 4. That minus 4 is a horizontal translation. But 5 is outside the radical sign, so it's vertical. Okay, so my answer will be 4 units to the right and 5 units up. And this is the only one that looks like my answer. 4 units to the right, and 5 units up. Okay, so there is going to be so many. Remember, you have your calculator. You should be able to do this. And then there are transformations of cubic function. This is cubic. Already you see that this is, first of all, that's a negative sign. Because that's a negative sign, we have a reflection. There is addition inside the original function. So 1 unit to the left, horizontal translation, and so of a cubic function. All right. Before we get too far, one thing I want to go and make sure we do now is we want to make sure that we know how to solve absolute value equation. Let's make sure we know how to solve absolute value equation. So where I'm going now is the practice test. So the practice test is in there's practice test in Blackboard Unit 1 folder. So let me go to, and so this is 2.3. I'm looking for the practice test. Is equal to 1. First of all, you eyeball the equation. It's an equation this time. Eyeball the equation. Make sure that the absolute value of that function is not negative, because absolute value of any number cannot be negative. If it's negative, that's all. You don't need to solve it. No solution. But in this particular equation, the absolute value is equal to 1. So there are two things you're going to do if the sign is equal sign. You will do x, the quantity inside the absolute value sign is equal to 1, or you are solving two equations, or the quantity inside the absolute value sign is equal to the negative of the number on the right hand side. Then solve each of them. Plus 2 on both sides, I have x is equal to 3. This is one solution. Plus 2 on both sides, I have minus 1 plus 2 is 1. So x is equal to 1. So I got x equal to 3 or x equal to 1. In other words, there are 2 zeros. Of course, when you graph an absolute value function, it can cut the x-axis 2 times. So there are 2 zeros. Okay, you can graph it, or you can, if the question says solve analytically, I have already said that analytically means algebraically. And so if you're told to solve analytically, it means show or work. Even if you use your calculator, you are using your calculator to show your work. And it doesn't mean that you just write an answer. Also, I can be told to transform an absolute value function into a piecewise defined function. Again, suppose I have x minus 2 is equal to 1. Now I can rewrite it, or I can just say it's equal to 0. Let's just write it there like this. It's equal to 0. Let me write it like this. I can rewrite it in piecewise defined function. I will say f of x such that x is equal to, I will put braces x colon x minus 2 is greater than the number on the right. If it's 0, I'll put 0 there. You know what? Let me put 1 there. That way, let me put 1 there. So it's greater than 1 that way. greater than 1. Then the other piece, I am writing an absolute value equation as a piecewise defined function. So now I have another one. Another piece is going to be negative x. So I have x minus 2 is going to be less than negative 1. The sign of inequality will change. Because the sign of inequality changed, I'm going to put negative 1 there, and then I will solve. But anyway, we will come back to this. By the way, we will come back to this. Actually, there's going to be a question that, let me pull up that question right now so we can solve it. Okay, I see it already. I see one question like that. All right, so everybody look. I already gave an example of this. The absolute value of a function cannot be negative. So if you're given an equation like in number 16 to solve, you quickly say no solution. Why? Because they said that the absolute value of the function is less than negative 13. Cannot be less than. Cannot be negative anyway. Well, you can actually solve this because it's an absolute value. Okay, but if it says equal sign, then you will say no, it cannot be negative. Okay, because this is less than, this is what you're going to do. If the sign of inequality is less than, then you bring the quantity on the right-hand side. We are solving it because it's an inequality. If it's an equal sign, we say no solution. I'm repeating that. So negative 13 is less than, bring down the quantity inside the absolute value sign is less than negative 13. By the way, I'm supposed to put negative here. That's positive. Okay, so this is going to be 13 is less than the quantity in the middle. In other words, you change the sign on the other side and put it here. 10 minus 16x is less than the way it is. Then solve. I am going to start solving by saying minus 10 on both sides. Minus 10 on both sides. Minus 10 on both sides. You are solving, remember, it is a compound inequality. You solve the three sections together. It's a compound inequality. Okay, so I will just cancel this one because they cancel. And then I have 3 on the left-hand side is less than negative 16x is less than negative 23. I haven't finished solving because I should have the coefficient of x in the middle to be 1. It's not 1 yet. So I will keep isolating x. Divide all the three sides by negative 16. Divide by negative 16. That way, I will finish up with positive 1 as coefficient. All right, now I'll cancel. This will cancel. So I'll end up having negative 13 is less than x, and x is less than negative 39. You could be told to draw a number line to represent your answer. I hope you know that this number here is greater than this number. Okay, so you can actually graph it. Remember, there's always going to be an answer because this is a practice test. Okay, so let's find another absolute value equation or inequality and solve. Okay, so we now let's find another one. There are so many examples in the, okay, look at number 18. When the absolute value has greater than as inequality, then you will have two equations. So bring what is inside the absolute value sign, bring it out. I have 1 minus 4x is greater than 6. And then 1 minus 4x is less than negative 6. Whenever the sign changes, the sign of inequality changes also. Then solve the two inequalities. In other words, separate, you already have a compound inequality, then separate them. Okay. All right. So so what are we doing? I want to make sure you know that this is a practice test, because actually we are going to meet 2 times in a week and do a test. So next class I see you, we shall be doing the rest of the sections and reviewing for tests. If you can do all the questions in this practice test, you will do very good to go. Okay. And then I am going to start solving. I want to isolate the x on the left-hand side. So minus 1 on both sides, I have negative 4x is greater than 5. If I subtract 1 on both sides. Divide both sides with the coefficient of x, divide by negative 4. What happens when I divide by a negative in inequality? The sign of inequality switches. Don't forget all those things you learned in middle school. Okay, so now I have x is less than, sign of inequality changes. X is less than negative 5/4. That is, and then you could be told to graph it. I can graph my answer. You could be told to graph your answer. You draw a number line. This is 0. This is negative 5/4 or negative 1.25, somewhere here. Negative 5/4. Remember the question says less than, so this is open. Then to negative infinity. You could also be told to write your answer in interval notation, no problem. Remember, infinity cannot be closed brackets, so negative infinity, comma, negative 5/4. Both sides are parentheses. All right. All right. So, any question? Let me see if you have a question. Then we can do a couple more. What are we doing? We're actually doing whatever we can do. We worked on 1.2, worked on 1.3, 1.2, 2.1, 2.3. Okay, and we're now trying to see if we can answer, we should be able to answer some questions in the practice test. Okay, well, suppose I am given an absolute value, a piecewise defined function, and I'm told to evaluate the function. I haven't been told to graph. We shall graph it next class. But suppose I am given a piecewise defined function, which you will be given anyway. It's already in the test. And you are told to evaluate some numbers. I know you can do this with calculator, but this is long. You don't want, if you can, but it's too long to be doing in a calculator before you finish typing it in. So you can end. So you want to check the conditions. This piece of a piecewise defined function is possible when x is less than 0. So going to find all the x is less than 0 here. That's only one x less than 0. I will evaluate that. It will not work any other place. It can only happen, f of -2 can happen when x is less than 0. So remember, whenever you are given a piecewise function, defined function, and you are told to evaluate some numbers, conditions must be obeyed. These are the conditions. All right, so let me evaluate f of -2, which means I will bring down the first piece and I will substitute -2 wherever I see x. Negative is positive. F of -2 is 7. So I put the answer here. F of -2 is 7. Then I will look at my second piece of the function. This is a compound inequality. It says that this is only possible when it starts from 0 inclusive to 5 inclusive. In other words, 0 and 5 are included. So I'm going to look, what are the numbers from 0 to 5 inclusive? 1 and 3. So I will evaluate 1 and 3 in the middle piece. So when x is equal to 1, f of 1 will be evaluated in this piece. So I have -1, which is going to be -1 anyway. So f of 1 is -1. What about f of 3? It works for the middle piece, the compound inequality. -3 is going, when I plug in there, I will have -3. That's all, it's not even difficult. Okay, then I'm done with f of -2, f of 1, f of 3, but that's one more. All right, so I'm going to evaluate this last one, which is f of 8. I want you to know that I'm recording this, and I'll soon stop so that I'll show you how to. I want to show you how to access the class sessions, the class recorded sessions. I'll show you how to get them. Okay, I haven't evaluated 8. So the compound inequality, the piecewise defined function says that whenever x is greater than 5, then we can use it to evaluate 2x. 8 is greater than 5. Therefore, it's a candidate for the third piece. So I'm going to say 2, substitute 8, and that is 16. So you can do this with your calculator, but trust me, it's easier to do by hand. There are some things that are easier to do with calculator. Some, if you think you want to put this in your calculator and finish, by the time you finish putting it in the calculator, you have taken that more time, and you might make mistake using the putting in the compound inequality. So do whatever you can do with your calculator, but don't forget that you still have your brain there. Okay, so you have evaluated all the numbers in the piecewise defined function, obeying the conditions for each piece. You must obey the conditions for each piece. Well, next class, we are going to be graphing the piecewise defined function, and we shall be finding the difference quotient. We shall be proving the difference quotient. All right. Let's even function and odd function. Am I taking? Okay. When a function is even, then it has y-axis symmetry. What does y-axis symmetry mean? An even function, let me write it. an even function also has y-axis symmetry. What in the world is y-axis symmetry? Okay, if I'm given a function f of x, if I change the sign for x in that function and it gives me the original function, then it has a y-axis symmetry. So every even function has y-axis symmetry. Well, let's try this one. Let's see if it's an even function. In other words, let's see if it's a y-axis symmetry. What I'm going to do now is I'll do f of negative x. So where I see x in this function, I'll plug in negative x. So negative x to power 4 minus 8 into negative x squared plus 7. Now I'm going to evaluate this function. If it gives me the original function, I will say it is an even function. And therefore, it also has a y-axis symmetry. Okay, when I evaluate, this is even. The exponent is even, so therefore the negative there doesn't really matter. This is even also, so I have negative 8x squared, and this is 7. Therefore, f of negative x gave me the original function, which means this function in number 20 is even and has y-axis symmetry. Okay, let's see, do we see any odd function? And by the way, if a function is odd, every odd function, if you put in f of negative x in the function, it will give you a negative f of x. So this is an odd function. Every odd function has origin symmetry. So let me look for one. If I don't see one, you can figure that out. Every odd function has origin symmetry. Well, sometimes students ask, okay, what about x-axis symmetry? X-axis symmetry, x-axis symmetry whenever you have y and you change the sign of y and it gives you the same as y. In other words, you are changing the value of the function. If you have y and you change it to negative and it gives you back y, that function has x-axis symmetry. So when you are looking for x-axis symmetry, change the sign of y. If it gives you the same, it has x-axis symmetry. If you're looking for origin symmetry, change the sign of x. If it gives you the opposite, then it has origin symmetry, and it's an odd. When you're looking for y-axis symmetry, change the value of x to negative. If it gives you the original function, it has a y-axis symmetry. Therefore, it's an even function. I said a whole lot there, but I want you to read it up and see that it's not as bad as people think it is. Okay, solve the equation. Everybody see. Don't rule number 23 out. Don't say it is, even though it's an equal sign, it's an absolute value function, but you haven't isolated the absolute value. So the first thing we want to do is to isolate the absolute value. So 9x plus 4, absolute value, we go to the right. I'm throwing it negative 11 to the right. So I have 11 minus 5. We don't have all the time to take in this. 11 minus 5 is 6. Therefore, the right-hand side is positive. We can go ahead. So 9x plus 4 is equal to 6, or 9x plus 4 is equal to negative 6. You solve this equation 1, solve this equation 2, and get to x-intercepts, 2 zeros of the absolute value function. I'm going to stop here. We have only 6 minutes. So we have only 6 minutes to go. Don't worry about attendance, because I told you some people do a whole lot of them like that. And for something like this, you can actually use your calculator again. It says find f of x at the indicated value, the same thing. All right, so I can go back and say f of 4, I'm already given the function. So f of negative 4 is equal to radical. X is here, so I'm going to put negative 4 there, to power 3 plus 68. And I know that negative 4 times negative 4 is 16. 16 times negative 4 is 64. So I have square root of negative 64, because remember, this is cubic. So 64 plus 68. All right. So negative 64 plus 68 is 4. Square root of 4 is 2. So when x is negative 4, y is 2 in that function. So we can, and you can put it in calculator again, you get the same answer. You can put it in calculator, you get the same answer. All right, so you can be given a graph and you are told to read the graph. If you're told to read the graph, they drew the graph for you. They did not give you a function, but you can actually find. Question says, for A, when x is negative 2, what is y? So you go to negative 2. That is it right here. So when x is negative 2, y is 0, you put it here. That's it. That's all. When f is 0, actually, when x is 0, right here, what is y? So I will trace it to, you see, it is 4. So 0, 4. When x is 0, y is 4, and so on. So that is how you complete that. So you can actually evaluate graphs. And also, if you go to PowerPoint, suppose you forgot how to do some of these, you can actually go to PowerPoint and read up how to do that. You can be given a table and ask if the table is a function. All right. And you will be told, is it a function? Remember, if there is a repetition in x, it's not a function. But if it's a repetition in y, it doesn't really matter. If there is a repetition in y, it does not matter. It's still a function. But if there is a repetition in x,